Hello. Hey guys. How's it going? Are we there? Can we get some people there? Oh, I like your reindeer ears. Those are so fun. And Henry's all dressed up. Are y'all having a Christmas party today? Christmas party at the co-op? I'm kind of jealous that I don't have reindeer ears. I just screenshotted this screen, and Olivia, your face is classic. I'll show it to you later. Mine's pretty weird too, but yours is the best. All right. We're missing Polly. Okay. You guys have paper? Because what we're going to do today is we're just going to work through some problems. Are there any, hold on, what am I looking for? Just a second. You guys make sure you have paper while I figure out what I was thinking I was going to do. I think it was this. Oh yeah, okay. All right. Are we ready? You guys are all talking to each other, but you're muted. And I don't know, I don't really like it.
Miss Tiffany, should we call the doctor? There's someone in need.
Who's in need?
Mackenzie has taken too much sugar.
Uh-oh. Did you guys just have like your holiday lunch or something?
Yeah, there was lots of candy handed out and
So you guys are
involved.
all wound up.
That was a problem.
Here's the good news.
For only one person.
Here's the good news. We are only going to be, this is going to be one of our shorter lessons. Because I'm not starting anything brand new, okay? Here's my plan. We are going to do some problems from 7-2. So if you want to label your paper, we're going to do some of the problems that I didn't give you for homework that are a little bit more confusing, that I feel like need more explanation. But instead of giving you a ton of notes, we're just going to work a bunch of problems. And then for homework, you're going to have a semester review. And I think this is recording. Yeah. So you're going to have a semester review and a few problems, not a ton of homework. You have the whole time to do it. Does anybody know what date we come back? I'm hoping it's January 11th because I cannot come back on the 4th. Does anybody know?
I don't know. I was thinking that it was the 4th, but
If it is the 4th, we will not have Algebra 2. My daughter gets married on the 7th, and I will not be teaching Algebra 2 that week. I will be barely functioning. Okay, write this problem down. And by the way, this is very hard to type, to draw these things. So you guys are just going to have to bear with me. I'm hoping that at some point, maybe over the holidays, I'll figure out how to use my little pad thing. Okay. So what we're going to review in today's lesson is we're going to be doing multiplying and dividing with radicals, okay? And some of these radicals will be cube roots and some of them will be square roots. The thing to keep in mind is you can only multiply, it has to have the same root, like cube roots can multiply to cube roots, square roots can multiply to square roots. Is there somebody back there talking? Because I would like for that person to stop. If she's not in class and is super hyper, then she may need to go somewhere else. And I'm not mean, I promise, but my students are very distracted and it's hard enough to teach on Zoom. Are you giving her the what for, Olivia, and telling her to shut her face? Shut her reindeer face. That's what I want her to do. Okay. Oh, here's Polly. All right. So here we go. Hi, Polly. Polly, we are just going to be working some problems. Okay, we're in 7-2. So here's what you're going to do, and follow me with this because I probably have a little bit of a different method for doing this than your book has. But what you're going to do, it's okay, Polly. I was actually 5 minutes late too because Joe went and picked up Chipotle for us, but then the order wasn't ready on time and I only had time to eat a few chips before class started. Okay, here's what I'm going to do, okay? I'm going to make this cube root, and even, so when you're multiplying radicals, okay, you multiply the numbers underneath, but instead of actually doing that multiplication, I'm just going to go like this. And here's why, because I'm about to break it down and look for triplets. It's a waste of time to multiply it and then separate it again. You can, you're allowed to do that, but you don't need to do that. So then, all right, we're going to break these down. Remember, we're looking for triplets because it's a cube root. Okay, I'm going to circle those because they're prime. For the sake of time, well, actually, I'll just do it this way. 16 is 4 times 4. Excuse how messy that is. And then each of those 4s is 2 2s. Here's a 2, here's a 2. Here's a 2, here's a 2. Once I do that, I've got all my prime factors, okay? So then what I'm going to do is look for triplets. The only triplets here are these 3 2s, okay? 1 comes out, 2 die. And then look what's left inside. This one, and this one, okay? So here's what we're going to do. The 2 is going to come out. We're going to have to leave the cube root, and then because there's multiple ones inside, we multiply those. So 3 times 2 times 2 puts a 12 in there. So that'll be 2 cube root 12 is that final answer. That's as simplified as it gets. Questions? Concerns? All right. Ready? Can I clear it? Do you need another minute, Polly? Okay. All right. So like I said, what we're going to be doing, we're just going to work problems and I'm going to explain them as we work them today. Okay. That's like, I felt like that was the best use of our time because I can't teach a whole lot of new stuff right before Christmas break. So let's do this, but there's stuff that you guys need to know for when we come back. And it's kind of a review from Algebra 1. You would have done this in Algebra 1 at least to some degree. All right, this is the square root of 7x to the 5th times the square root of 42xy to the 9th. Okay. So this time we've got 2 things here, okay? We've got 3. We've got numbers, but then we have variables. So let's do the numbers separately first, okay? So I'm going to come down here with my 7 times 42 under the same radical. We will deal with the x and y in a minute. So let's just leave that, kind of leave space for that, but come back to it, okay? 7 is already prime. 42 is going to be 7 times 6. Circle the 7. Now, at this point, 6 is not prime, but when I break 6 down, I'm just going to get 3 times 2. So that's not going to have twins. So I can save time and not do that. That's just going to stay. So for the 7s, 1 comes out, 1 dies, and the 6 is going to stay inside. Now, this is what I do, okay? Let's see, I'm going to put my answer like right down here. Let's do this. So I'm going to put the 7. I'm going to leave some space. Then I'm going to put the radical, and then I'm going to put the 6. And that leaves space for any variables that are going to be out there, okay? Now, let's look at our variables, our x's. We've got x to the 5th and x to the 1st, okay? Same base. You add exponents, that gives us x to the 6th, okay? Now, if I write out 6 x's, remember, we can do this or we can just divide by 2. But if I write out 6 x's, then I have 3 sets of twins, okay? So 1 from each of those comes out, which means that 3 x's come out. That's x to the 3rd, and there are no x's left inside. Okay, if it's even and you're doing a square root, there's not going to be any that get left inside. All right, then our y to the 9th. So, okay, I have 9 y's. Let's do this without, let me show you a little, I'll put it here for now, but let me show you a little shortcut. Y to the 9th, I can separate it into the even and then just the by itself. So this could be y to the 8th times y to the 1st, right? Y to the 8th is gonna, you just divide by 2 when you're doing it this way, okay? That's y to the 4th and then a y left inside. So you can like write them all out and you can circle the twins, or you can just divide by the index. So that's gonna be your final answer down there. 7x to the 3rd, y to the 4th, square root of 6y. Okay, we good? Can I clear? Okay, let's do 21. One of the things I noticed as I was looking through this is like, for these problems, the reason I'm doing them is like every one introduces like another little step that I want to make sure you guys know what to do with. So that's why I just decided to do it this way. All right, 5 y to the 3rd. So this is a cube root, 3 times cube root of 5y to the 3rd times 2 cube root of 50y to the 4th. Okay, so the new thing that's thrown into this one is that we have coefficients going into it. Okay, so when you have that, you're going to multiply those first. There's going to be a 6 in front, and then the cube root, okay, and then we'll deal with the 5 times 50. We'll get to the y's in a minute. If you want to go ahead and do the y's, though, actually, I can just put those. Those are going to be 7 y's total, because it's y to the 3rd times y to the 4th. And then remember, because we're doing cube root, we're looking for triplets. Okay, so we've got our 5. This 50 is going to break down into 5 times 10. And this 10 is going to break down into 5 times 2. Okay, and we're looking for triplets. And there are 3 5s. So 1 gets to come out, 2 have to die. Remember, 2 die this time. And the thing you have to do with this is that the 1 that comes out has to be multiplied by the 6 that's already out there. So now you have a 30, okay, because the 5 came out and got multiplied by the 6. I'm going to leave a little space for y's, and left inside is a 2, okay? And then we have y to the 7th. Now this time we're looking for a cube root. We're looking for triplets, okay? I don't want to write 7 y's with this mouse, so just imagine 7 y's grouped into 3. There's 3 y's here, boom, boom, boom. That'll represent a y. 3 y's and then 1 y left outside, okay? So there's 2 y's that get to come out. That's 30y squared, 1 left inside. So remember the last time the way I did this. So this is a cube root, okay? If I break down this y to the 7th into y to the 6th times y, I'm doing that because 6 is divisible by 3. So I could divide right there, okay, and get y squared. Does that make sense? You can divide by the index. Here's the good thing. If it doesn't make sense, then just write them all out. You can do that every time if you want to. All right, any questions about that? Okay, now we're going to go to 27 and we're going to practice something called rationalizing a denominator. Now, this will be a review from Algebra 1, but depending on how long ago that was that you did this one, you may not remember this. But here's the deal. In the world of math, okay, there's some rules. One of them is that you cannot leave a radical in the denominator, okay? It's very, very bad. So we have to get rid of it. It's called rationalizing the denominator. Now, whatever is in the denominator, whatever is under the radical is what you multiply top and bottom by. So we're essentially multiplying by 1, except that it's in the form, in this case, radical 2 over radical 2, because whenever you put 2 of the same things in a fraction in the numerator and denominator, that's a 1. So it doesn't change the value, but it can change how something looks, okay? So on the top, when we do this, radical x times radical 2 is going to be radical 2x, okay? Because you multiply numbers that are under the radical. And then here, radical 2 times radical 2, technically that is the square root of 4, but the square root of 4 is 2. And here's the thing, something I want you to remember is whenever you multiply a number by itself under the radical, you automatically have twins. So the radical just goes away, okay? That's kind of the shortcut there. And then this is your final answer because you no longer have a radical in the denominator. And so it's done. It's the same thing as this, it just looks different. Let's do another one. Let's do one with a cube root. This is number 29, by the way. We've got cube root of x over the cube root of 2. Now, here's what you have to do with this, okay? You can't have a radical in the denominator, but in order to get rid of a cube, you have to have 3 of something, right? Not just 2. So for this, what we have to do is this. We actually have to multiply top and bottom by the cube root of 2, not once, but twice. Okay? If this were a 4th root, I don't think you're going to have, actually you might have one like that. You would multiply by 4 times and so on, okay? So when you do this across the bottom, when you multiply these, you've got triplets, right? And they're all 2's. So the 2 just gets to come out. That's why you do this. That's the whole point of this. And then on the top, since it's all cube roots, we're just going to multiply everything underneath and we get 2 times 2 is 4 times x is just going to be 4x. So that is the cube root of 4x over 2. Cube root of 4x over 2. All right. Any questions about that one? It's not too bad, right? Let's do one where we throw in some variables though. Let's do, hold on. Oh, here we go. Let's do this one. This is actually number 47 in your book. Okay, this is 5 radical 2 over 3 radical 7x. So the problem here, the one that we actually want to get rid of, oops, is the radical 7x. Okay, everything else in this is fine, but we want to get rid of the radical 7x. So what we're going to do is we're going to multiply top and bottom by a radical 7x. Okay. Now, the thing that's different here is we've got coefficients. So you've got to be careful. When we do this, radical 7x times 7x, we get 7x. It comes out of the radical, but there's still a 3 here. So that's actually going to be 21x in the denominator when it gets multiplied by that 3. And then on the top, we've got 5 stays on the outside. 2 times 7x is going to be 14x. And that will not simplify it all. If it could simplify, then you would need to go ahead and simplify it. But this one will not simplify. Okay, 14 is just 7 times 2. All right, let's do another one. Can I erase? Let's do, this will be from number 51. Why can't I do a circle? There we go. Okay, 3 radical 11x to the 3rd y over -2 radical, try that again, 12x to the 4th y. Okay. So here we go. First of all, well, let me back up for a second. So here's one of the things you need to think about here. This could actually be simplified, this 12x to the 4th y, before we multiply. Here's the thing, you can simplify it before you multiply, or you can multiply and simplify it after. I don't think it matters either way. I'm gonna simplify after, okay? So I'll show you what that is gonna look like. So the part that we need to multiply top and bottom by is everything under the radical, which in this case is 12x to the 4th y and 12x to the 4th y. Okay, so when we do that, this is going to get kind of messy here. Okay, so pay close attention here. When this happens, all right, this comes out of the radical completely down here. Okay, and what you're left with, don't forget there's a -2. So what we have down here is -24 x to the 4th y. Okay, and then the top is where it's going to get more involved. All right, so let's look at this. Let's think through the best way to do this. So just like when we were doing the multiplying before, I'm going to come down here actually, because I want to have some space to show you what I'm doing here. Again, there's always kind of a couple of ways you can do it, but there's certain ways that are the most efficient when it comes to stuff like this. Okay, so there is that 3 on the outside that we cannot forget. I'm going to put it here, but then on the inside, remember, we're going to multiply, but I am not going to actually multiply. I'm just going to put 11 times 12. I will go ahead and multiply the variables. So that gives me x to the 7th y squared. Okay. And then if I break this down, okay, the 11 is already prime, right? So I'm going to circle it. 12 is going to break down into 4 times 3. I'm going to circle that 3. The 4 breaks down into 2 times 2. And there's my twins right there. Okay. So let's pull up another color for this last little bit. So here's what's going to happen. A 2 is going to come out. A 2 is going to die. And with this, there's a lot that is going to happen here. So let's try to keep up with all of it and not get lost. So there's a 6 on the outside. I'm going to leave a little space. And then I'm going to take care of whatever else is here, which is a 3 and an 11 get multiplied together. So I make sure that all of the circled numbers are used, okay? Then if we have x to the 7th, okay, that means there are 7 x's. So x to the 6th times x to the 1st. X to the 6th divided by 2 is x to the 3rd. So 3 x's come out, 1 stays inside. Okay. And then there are 2 y's, so that's easy. There's one set of twins. A y comes out, a y dies, and nothing is left inside. All right, now you would think we were done, but guess what? We're not. But we're close. So what we have to do here now is just reduce. You always have to reduce. Should we pick another color? Let's do another color. I haven't done purple, but I feel like purple might be ugly with these. Let's see. Okay, so when you simplify these, okay, the first thing I'm going to look at is the 6 and the negative 24. And I'm going to make a blank fraction here. I know that 6 over negative 24 is 1/4. That negative can stay down there or it can go out to the side. Doesn't matter. It's the same thing. It can even go to the top. It can only be in one place, but it can be in any of those 3. One place at a time, I mean. And then look at this. 3 x's on the top will cancel out 3 on the bottom, and that leaves me 1 x still on the bottom. 1 y on top will cancel 1 y on bottom. The y's are gone completely. And then we still have a radical 33x. Now, nothing under that radical is eligible to be simplified. It's against the law. It's stuck up under there. It cannot be simplified. That is the trickiest of those kinds of problems that you would have to do. It's long, it's a lot to it, but if you do it step by step and are careful, you'll do fine with that. Okay. All right, we're going to do one more, and then I'm going to give you homework. And then you'll be done with math, except for doing the homework until winter break. You get your winter break, is what I'm trying to say. My brain is very fried. It is a busy week in the FLVS world. Okay, so what if we have something like this? 3 plus radical 5 over radical 5. Okay, same situation. That this is going to be a pretty color combination. Wait till you see what I picked. We want to get rid of radical 5. Okay, that's all we want to get rid of. See, isn't this a nice color combo? I like it. Okay, now here's what's going to happen when we do this. The bottom is, the denominator is going to be 5, just plain old 5, because radical 5 times radical 5 is 5. On the top, though, this is something we haven't had to do. You actually have to distribute, because this is a binomial multiplied by a monomial. So we go 3 times radical 5 is 3 radical 5. Radical 5 times radical 5 is just 5. No, stop. Hold on. Dang it. Are y'all still seeing my board? Okay. It's trying to make me pay. Okay. I might be getting the full Zoom though, because we're going to Zoom my daughter's wedding. And so then we could have math class for like 2 hours and not have to stop at all. Merry Christmas. Okay, so this would be your final answer. Any questions? Okay, that's all we're doing today. Let me tell you what you need to know for your homework. First of all, chapter 6 test. You already have it. I sent it to you. When you are done, please mail it to me and I will grade it. Okay. Where did my notebook go? Oh, then I want you to do from lesson 7-2. I want you to do 18 to 34 even. And then I'm going to be emailing you an Algebra 2 semester review. Okay. And when you get that, and I will email that today, when you get that semester review, you'll see some of the, let me see if I have the paper here. Yeah. So you're going to need to print it out. Okay. It's multiple choice. Do your work like on the side. Okay. And then some of them have like a big X on them, or a star, I should say. Those are optional. They can be bonus or you don't have to do them. Okay. And I will email those to you today. Are there any questions? Let me write this down actually, that I did the 18 to 34 to them. Okay, then let's see. So I will make sure, I'll find out about the coming back, what we're gonna do. But, and I'll let you guys know. Mail me those chapter 6 tests, Maggie, Polly. I want everybody caught up by January. Olivia, you have a chapter test that you're going to send me with your chapter 6. So everybody caught up by January, and we'll start fresh with our second semester. Okay? Thumbs up there, Maggie. I hope you guys have a great holiday. Mine is going to be super busy. We have a lot of people in town and more people coming. This is the week of mathematical catch up. So, Polly, remind me, because what happens is when I close this, it has to take like a little while to convert. And sometimes by the time it's done converting, I have forgotten that I need to send it. Because what I'll need to do, it converts, then I need to put it on my YouTube channel. So actually, check my YouTube channel later and let me know if you need the link, because the file is always too big for me to send. That's why I put it on my YouTube channel. All right, guys, I hope you have a wonderful Christmas, and I will miss you, and I will see you back in January. Text me if you have questions on homework this week or on that review. You can also text me, like if you're working next week or in 2 weeks. Feel free to text me anytime. I'll respond. I'm going to start talking about Henry now because he ran out of the room. Let's say bad things about him. Let's all share all of, I'm just kidding. I'm just kidding. All right, bye guys. Merry Christmas. Poo-poo name? Yes, like a poo-poo name for Henry. Bye.